Right, so in part 2, this is our scheduling discussion, and we are continuing with specific algorithms. We'll start off with the non-real-time ones before we discuss the real-time schedules. Right, so previously we said preemptive schedules were ones where processes can be stopped midway so others can run. Non-preemptive means the processes can get to run for as long as they want to. Right, and we talked about concepts such as CPU utilization, throughput, turnaround time, waiting time, and response time. Okay, so let's look at some of the things we are going to be picking up, the algorithms that we'll be looking at. We'll start with the ones that are not real time. As far as algorithms, you have to consider whether or not the system you have is for a real time. Well, the system you have is real time or it's not real time. A real time system is one where deadlines are hard. If the deadlines don't or are not met, then something catastrophic can happen. For example, if someone has a device in his heart to monitor the rate of his heartbeat and administer some amount of electricity to keep the heart rate at a certain pace, if the system were not responding quickly enough, the person would die. But I don't think anyone would maybe die if you were trying to make a phone call and it didn't go through. Or maybe you turned your computer on, but it took 10 minutes to boot instead of 1 minute. In that case, it's not really a real-time system, right? So real-time systems, so most of the computing we do these days, for most people doing personal computing, it's not real-time. Real-time, usually if it has to do with health, with emergencies, sometimes in production, for example, in a factory, certain things are being produced, they have to be worked on at a certain period of time, else the item is not needed anymore, right? Let's say someone is building a car and they poured the metal and they've melted the metal, poured it. If he doesn't work on it quickly and the metal hardens, that's it. They will have to start the process all over again. So some things are real time, some things are not. The algorithms we are going to consider, these you've met in real life. First come, first served. There is shortest job first, which means that whoever has the shortest amount of time to run gets to go. Round robin is a schedule that people may have been exposed to as children. Usually when you are sharing something, everyone gets a turn. Maybe you want to play with a toy, your siblings want to play with it too. You agree to rotate the toy amongst all the different children. That's round robin. Priority schedules usually would mean they would look at some property of the processes. It could be the user, it could be the computer that's submitting it, it could be anything to say, okay, let's use that for our priority to decide who goes first. Right? And for all the schedules, the reason why we said preemptive, non-preemptive, for the schedules we've discussed, such as first come, first served, shortest job first, we have to consider whether or not we are allowing, and also, priority schedules, we have to consider whether we allow preemption or no preemption. Let's start with the first one, first come, first served. Right. So first come, first served is whoever gets there first, whichever process comes in first, gets to go. Right. So for example, this is an example we're using before. We have Abena coming in at 10, Kofi at 5, Alice at 10, Sam at 10. If this is to be a first come, first served schedule, we also have to ask ourselves, is it preemptive or non-preemptive? Let's start with non-preemptive. Right. That means that whoever gets there first gets to go. So Abna gets in at 10 and she's running for 11. So that means from 10 to 10, 11, she gets to run. Remember, it's non-preemptive. First come, first served. Who was the second person who came in? Even though Abna finished at 11, by the time she finished 11, Kofi, Alice, and Sam are in. But since it's first come, first served, Kofi goes next. Right, so 10, 11 till 10, 16, that's Kofi's time. And first come, first served. Sometimes there's a tie between two, but if it's written in a list, I would, if it's first come, first served, pick the first one. Remember, if you see these exercises, you can ignore the priority, or if it's a tie, decide to pick the one with higher priority. But even if it's a priority and there are numbers, you have to ask, what do the numbers mean? In this case, I would say the higher the number, the higher the priority. Okay, so greater means high, right? There's somewhere greater means low, right? So that means these two have run, and Alice and Sam, let Alice follow up from 10:16, running for 10 minutes, that means to 10:26, and finally Sam, who's running from 10:26 for, I think I missed something. Okay, so this went for 11, this went for 5, this went for 10, and the last person is going to go for 4. So 10:26 to 10:30. So if you look at these, we'll also look at some of the criteria. So the criteria was CPU utilization, throughput, turnaround time, waiting time, response time. Usually when we say throughput, we look at a period of time and say how many were finished, right? So for example, if someone said, what's the throughput for the first 10 minutes? It's just 1. What's the throughput for 20 minutes? So from 10:00 to 10:20, I had done 2. So throughput usually depends on some period of time, right? What about response time, right? Response time is from the time when someone requests something, so like here 10:00 to when they actually start. So the response times, okay, so response times, currently we have 0 for Abena, she didn't wait at all. Kofi started at, wanted to start at 10:05, but got to run at 10:11, so that means that there was about 6 minutes waiting. Alice got to run exactly when she came in, so response time 0. Sam got to run at 10:26, but came in at 10:10, so 26, 10:10, response time 16. So response time is usually how much time before you responded, or how much time from when you came in to when you actually started doing some work. Now if you have a computer, if you click a button, someone would say the response time, so let me do right click. You could put a timer to it and say from the time when I clicked to when I actually see something, there's a small delay. That's your response time. Maybe you have a program, maybe, let me stop this, right? You have a program that you want to run the moment you click. So I'll say, okay, my task is I want to run CentOS, right? From when I clicked, see there's some amount of time still going before anything shows. This is all part of the response time. I've not been timing myself, I think it's been a few seconds. Wow, this program has a long response time, right? And then boom, so this is my response time, right? But remember, my task is still not complete. I said I have to wait until it starts, and then I have to press. So response time was when I actually saw something happening, right? From that time all the way to, okay, it's still not started yet, until it starts. So when someone says response time, it's usually when you first get something going, you first see something on screen. Usually for interactive systems, something you click, something you ask to start, you can determine the response time. And then based on your task, so if I said I want to see when CentOS would start, I'm waiting, alright, so it started. From the beginning when I click to now, that is my turnaround time, right? So let me close it and then we get back to alright, so we are continuing and we are seeing different response times. So 0, 6, 0, 16. And for response time, we are simply looking at when someone came in, so 10:10 to when they actually got to run 26. That's the response time. For waiting time, usually we would look at, for this one, nobody was interrupted, so the response time is the same as the wait time. So waiting time, usually if you are interrupted for any reason or moved around, you'd have to include that in your wait time. Okay, so first come, first served. Alright, so let's do first come. Okay, that's fine. First come, first served, no preemption. Let's look at the turnaround time. Now, to consider the turnaround time, so I'm going to add another. Sorry. That's from when you came in until when you finished. This guy came in at 10, ends at 11, so turnaround is 11. Came at 10:05 and ended at 16. That is another 11. This one came in at 10:10, ended at 26. That would be 16. This one came in at 10:10 and ended at 30. So turnaround is 20. So for turnaround, you'd have to look at when you came in until when you finally ended. So this is non-preemption for first come, first served. Alright, let's look at another type of schedule. Let's say shortest job first. So the idea with shortest job first is you are going to pick the job with the shortest amount of time. So let's clean this up and do a shortest job first. Let's do non-preemptive first. So we're going to clean up all the stats and clean up everything. So shortest job first. Now at 10:00, Abena was in and she's running, and we said no preemption, so that means she can keep running. So she starts at 10 and ends at 10:11. When she ends at 11, other people are in. Right. For the other people that are in, we are going to pick the person with the shortest job. Right. Now, note that, for example, if this Sam, so I'm just going to make this change to make it more exciting. Right. So using this now, just to make you have some excitement and see some differences. If this thing had ended at 11 and Kofi and Alice were in, that means at 11 these two are in, but Sam is not. Then between Kofi and Alice, we pick the person with the shortest job. In this case, 5. But if Alice had a shorter job, she would go ahead. If Sam was also in, so this was what it was initially. If Sam was also in at that time, that's at 11, Sam were in, then we have to pick Sam to go. So if in this case, Sam would get to go. That's from 10:11. This is the shortest job, no preemption, and would end at 10:15 because you're supposed to go for 4, right? And after this, we go and ask ourselves, who is the shortest job now? There are 2 people left over, Kofi and Alice, and between Kofi and Alice, Kofi has a shorter job, so he's going to go from 10:15. He's going for 5. From 10:15 to 10:20, right? And then you also have Alice, who wants to go for 10. She goes from 10:20 to 10:30. Alright, so now let's look at the different things. Response time, how quickly were they able to respond? Alice responded 0 seconds. Kofi was at 10:05, so his response would be at so he's running at 10:15, so response is 10. Alice came in at 10:10, response at 20, so 10 to 20, that's another 10. Sam came in at 10, response at 11, response is 1. Right. Let's look at turnaround time. For turnaround time, we'll be looking at when you came in to when you ended. Right, so this one is 11, turnaround time. Kofi's turnaround from 05 to 20, that's 15. Right, Alice came in at 10 and finished at 30, so that's it. And Sam came in at 10, sorry, he finished at 15. Because it was for 4, okay, it's finished at 15. and so turnaround is 5. Right. So that's the various turnarounds for non-preemptive. Let's do preemptive shortest job first. So you see, non-preemptive, we don't stop people from running. It's easy to do. Okay. Let's duplicate everything here and let's do a copy. Okay, shortest job first with preemption. Let's do this. So for preemptive, we are going to be stopping people if people arrive and look at who has the shortest job, right? So Abena comes in, she starts at 10. But preemptive means if someone comes in with a shorter job, they will get to go, right? But while Abena was running at 05, Kofi came with a shorter job. So Kofi would then interrupt, right? And that means Kofi would run from 10:05 and ends at 10:10, right? Meanwhile, Abena has been waiting, right? She has 6 more to go, but she's waiting. Now, at the next time when someone arrives, which is, so when either someone stops, like in this case, Kofi has stopped, or someone arrives, then we have to check and see who has the shortest job. So Kofi stops and someone has arrived. Let's see who has the shortest job. Currently, Alice would have 6 left over. Sorry, Abena has 6 left over. Alice, who is coming in, wants to do 10. Sam wants to do 4. So of all the jobs there, the person with the shortest job is Sam. So Sam is going to go. So he's going to go from 10:10 to 10:14. Now, when I do this, I usually adjust the time that's left over. Right. That means if you run for a bit, you're interrupted. Now, there are some people who would run this algorithm and not change the job time left over. If you do that, you could have someone would say starvation. Starvation would be worse. So what we do usually is, if you run for a bit, I would change your time. I would take off the time, and what you have left is what I use for your job length, right? So next between Abena and Alice. Abena wants to run for 6. Alice wants to run for 10. So Abena is going to get to run. She's going to run from 10:14 to 10:20, right? And then finally, Alice gets to run, and that's from 10:20 to 10:30, right? So you can see there are some people who have been waiting, right? Waited for a while. This one, 10:10, spent this time waiting. Sorry. Waiting and waiting. Alright, so let's look at the various criteria. So response time. Abena got in good response time, 0, didn't have to wait for anyone. Kofi came in, and the moment he came, got to run, so 0. Alice came in at 10:10 as well, so had to wait a bit, so had to wait up until 10:20 to run. So responded in 10, and then Sam came in at 10:10, got to run at 10:10, so responded. Now we'll also add another computation in, which is the wait time. When there are no interruptions, wait time and response time are the same. But when there are interruptions, so in this case someone was forced to get off, the wait time and response time will be different. So for example, Abena responded in 0, but she actually is waiting between 10:05, because she got around from 10:0 to 10:05, and got back at 10:14. So there's a gap between the two times. Right. and that gap over there is the waiting. So the waiting time for Alice, oh sorry, for Abena, it's 9 over there, right? Waited for 9 because of the delay, right? Kofi didn't have any waiting time. He got to run and finished on time, right? Next is Alice. Alice came in at 10:10 and waited till 10:20 to run. Time 20, and Sam came in at 10:10, got to run at 10:10, waited for 0, right? And turnaround time from 10:00 to 10:20. That's how much time Alice spent. So Alice spent 20. Kofi spent 5. Sorry, Abner spent 20. Kofi spent 5. Alice waited a bit from 10:10 to 10:30, right? 20, and Sam only 4. Right. So that is with preemption. So preemption means that when someone comes in, you stop the things and you check out. Based if it's shortest job first, we are looking at the shortest jobs. So whenever, for example, Kofi came in with 5, we stopped everybody and realized, okay, between Kofi and Abena, 6 versus 5, so Kofi had to go. Right? So that's what you do when you have preemption. Right? Now the next one to consider is round robin. And what we said with round robin is, for round robin, usually there's some amount of time that is allotted for every process. So if you are doing a round robin problem, you have to ask, how much time am I giving each process, right, to take a turn, right? So let's do round robin, and I'll put in some specific amount of time, right? So I'll say round robin with 3. I'll give everyone 3 units of time to run. Okay, so let's do round robin. Right. Going to duplicate the same thing, create a copy. Alright, so round robin, I'm using 3. Alright, so I'm going to give everyone 3 minutes of time to run using round robin. Alright, so Abner comes in, runs for 3 units. Right, that means she'll run from 10 to 10:03. Right, stop. She has some time left over, right? But then by the time she finishes at 10:03, there's nobody else around, so she can continue, extend her amount of time. So she'll go to 10:06, right? So she got 2 units of time. She got 2 turns. Right, she got 2 turns, right? But by the time she finished her second turn, Kofi is in, and so Kofi can get to go from 10:06 to 10:09. He's done 1 turn. Abena has 6 done. She has 5 remaining. Kofi just did 3 out of 5, so that's 2 remaining. How much time he has left to go? Right. By the time Kofi finishes at 10:09, nobody's in, but Abena is the other person, so she gets to go for another 3. 10:09 to 10:12. Alright. And the next one to go for this, at 10:12, Alice and Sam are in. Right. Abner now has done 9, okay, and has 2 remaining at this point. She did 6, then 3, has 2 remaining. Right. So from her, the next person who can go, since there are now 3 people, so at 10:12 there are 3 people, 3 other people who are running, right? So from Abena, Kofi can take a turn. 10:12, but he only needed 2, so he's going to go to 10:14. Right. So Alice is available as well. So it's round robin, so it's sort of cycling between them. So just going through. Right. So next, Alice is going for 3 of hers. Kofi now has just 1 remaining, by the way. Right. So 10. Oh, just a sec. I have to make sure I haven't made a mistake. Okay. Went for 3, that was 6. Kofi went for 9, 2 remaining. Okay, so Kofi would have finished by now because he did 9, 3 the first time, 2 the second time. Alice is in, so Kofi has 0 remaining. 0. Okay, that's a good catch. Right. So Kofi has finished. So the only 3 people that are left is Abena, Alice, who has 10 remaining, and Sam, who has 4 remaining. Right, so those are the 3 that are running. Abena just went, Kofi went. Next person to go, Alice. It's just round robin, so everybody's taking a 10. So 10:14 to 10:17 takes 3 units. Right, that means she has 7 remaining. Right, then the next person takes a 10, which is Sam. Sam was supposed to go for 4, but he's going to have 3 of them. So 17 to 10:20, 4. He's done 3 of them, so has 1 remaining. The other person who has 1 remaining is some remaining is Abena. She has 2 remaining now, so she's going to do her 10:20 to 10:22. Right, next person to take a 10, 10:22 to 10:25, and that means there'll be 4 remaining. Right, keeps going. Alright, so 10:25 to 10:26, and now there's nothing remaining, and the only person left is Alice, and she can have the remaining 2 10s. 10:26 to 10:30. Alright, so this is what round robin would look like. So we'll go through and clear out the response times. So response time for Abena, she started 10:00, got to run at 10:00. Kofi came in at 10:05, but got to run at 10:06. That's 1 for his response. Alice came in early 10:10, got to run at 10:14, so response is 4. Sam came in at 10:10, got to run at 10:17, response is 7. So let's look at waiting time. Right. So what you probably are seeing is response time for round robin tends to be on average shorter than others. Right. Let's look at waiting time. When, by the way, for shortest job first, the turnaround time on average tends to be shorter than for the other algorithms. Right. Well, shortest job first is optimal for turnaround time. Okay, so let's go to waiting. So Alice has been waiting. Well, she had 3 over here, and then she also did, so she did some waiting 3, and then from 12 to 20 also did some waiting. That's 8 plus 3, that's 11. So 11, so you have to count every time she was off the CPU. Next we have Kofi. Kofi waited 3 over here. That's between 9 and 12, that was 3. And that was it, he finished. So he just waited for 3. Alright. And we have also Alice, who came in at 10:10. So she spent about some amount of time waiting. From 10:10, she was waiting. So that means Alice, say, a couple of times, we are not done yet. So there are 2 values she waited for. From 10:10 to 10:14, that's 4. And she also did some waiting, so there's 4 waiting here for 4, and between 17 and 22, waiting for 5. And for this one, also waiting for 3. Oh no, not waiting for this, is waiting for 1. So waited, so 1 plus 5 plus 4, that's total of 10. Right. Then we go waiting for Sam. Sam came in at 10:10. Didn't get to run till 10:17, so that's was waiting for 7 before she got to run, and he waited some amount of time between 10:20 and 10:25, so waited for 5. So if you add up all the wait times for him, that's 12. And 10 round is when you came in, when you ended. Came in at 0 for 10:0 for Alice, and then at 10:20, so that's 22. Came in at 10:05 for Kofi, ended at 10:14, that's 9. Alice came in at 10:10, ended at 10:30, that's 20. And Sam came in at 10:10, ended at 10:26, that's 16. Right. So these are the various waiting times. Right. So with this, we've covered the schedules: first come, first served, shortest job first, round robin. For priority, it just means you use the priority. It's similar to shortest job first, but you're going to be using the priority. I'll just do one to show. Right. And for priority as well, you have to ask yourself, are you allowing preemption or no preemption? Right. So priority, I'll do no preemption. Very easy. So Abner came in at 10. Is going to end at 10:11. Right. If there's no preemption, it means that all the time when she was running, even though people with higher priority, so I'm just saying, for the higher the number, the higher the priority. You have to ask when in an exam or in a question what it means. Some people assume that 1 is higher. If I haven't stated or it's not stated, you can write your assumption. I'm just working with this, saying the higher the number, the higher the priority. So even though she has priority 5, no preemption, she can continue, right? So no preemption. Right? If that's the deal, then she can continue to 10:11. But by the time she finishes, the person with the highest priority is Kofi, so he gets to go next from 10:11 all the way until goes for 5, so 10:16. Right. And then of the 2 people remaining, the person with the highest priority is Sam, so she goes from 10:16 for 3, that's 10:19. And then finally, I think I might have, there's something wrong with the times. 10:10 to 10:11, 10:11 to 10:16, 10:16 to 10:20, and then 10:20 to 10:30. So that's what the priority with no preemption would look like. If we were to do priority with preemption, let me add, that would be slightly different. I'm just going to make a copy of this. Okay, so if we were to do priority with preemption, right, that means that people can be paused or stopped when people arrive. So 10:10, because Kofi came in with a higher priority, Abner would have been forced to stop at 10:05, right? And Kofi has the highest priority, so he can keep running from 10:05 all the way to 10:10. time they finish, of the people that are running, the person with the highest priority, or the people remaining, the person with the highest priority, that's 5, 1 and 3. Abena has the highest priority in that case, so she can go from 10-10 to 10-15. And then the next person, they are all in. That means 10-15. Oh, sorry. She does for 6. So sorry, 10 to 10-16. She does for 11. So 5 the first time, 6 the next, followed by Sam. That's 10-16 to 10-20, and finally this one goes from 10-20 to 10-30. Right. So with priority, if there's preemption, that means when someone comes in, we check to see if the person has a higher priority than someone who is already running. If he has higher priority, like this case, Kofi has higher priority, he can interrupt. And then when he finishes, those who are in the competition can then check to see who has the higher priority. So hopefully with this, you've seen different ways scheduling can happen. First come, first serve, shortest job, round robin. Round robin has preemption built in. Right. Priority can be preemptive or non-preemptive. Depends. Right. First come, first served. Because your time first, whoever came first has the highest time all the time. This is non-preemptive. Right. Shortest job first is preemptive. Well, you can have a non-preemptive one where, like the one we're doing, someone comes in, someone's ready on, even though you have a shorter job, you have to wait. But you can have a preemptive version where if you show up and you have a shorter job, you interrupt. So these are the different ways that non-real-time algorithms for scheduling can be done. Right. Thank you. The next one will be for real time. Right. Thank you very much.